All right, now we're going to convert the other direction. We're going to take a radian measure, we're going to convert it to degrees. So I'm going to put, since I want to get rid of the radians, I'm going to put 180 degrees over pi radians. I'm going to do my canceling. Pi's cancel, radians cancel. And then I'm going to say that 2 goes into 180 90 times, which leaves behind a negative sign, 90 in degrees. And I get negative 90 degrees. So if I think about this in my head, negative pi over 2 rotates me down to here, rotates negative pi over 2, and 90 degrees puts me in the same place. All right? Same thing for number 9. So if you, at any point through this lesson, pause it, rewind it, make sure you're keeping up and understanding it. So I do the same math, 5 pi over 6 radian times 180 degrees over pi radians. My pi radians cancel, which is a good thing. 6 goes into 180 30 times. I get 150 degrees. All right. Once we see it, hopefully it's not bad. Number 10 is going to be a little bit different. I'm going to multiply by 180 degrees over pi radians. I'm going to cancel what I can. My radians cancel, and that's all. My pi doesn't cancel, so I'm going to say 540 degrees divided by pi. Right. Normally we don't have pi's in radian measure or in degree measures, so I'm going to do the math. 540 divided by pi, and I'm going to say this is 171.887 degrees. We need to remember, always round to 3 places unless the problem says differently or needs to be different. So I'm not, both of these are okay, but if they want the decimal, say 171.887. All right, they all don't, I mean, pi's don't cancel, but this radian's better. All right, next. We're going to talk about smaller parts of a degree. Not every degree in life is exactly an integer. All right, if you talk about latitude and longitude lines, not every house in the world is on a latitude and longitude line. It might be in between. So what we're going to do is we're going to break these down into smaller numbers. All right, so you're going to need some sort of calculator or something to get through these. All right, so what we're going to say, a degree is broken down into a certain number of minutes. Every degree can be broken down into a certain number of minutes. Now, I'm just going to tell you, if you just think basic, 1 degree is going to be 60 minutes. There are 60 minutes in a degree, just like an hour. Taking it any further, every minute can be broken down into a certain number of seconds. I'm going to tell you that there are 60 seconds in every minute. Kind of the same idea as time. So, if 1 degree has 60 minutes and 1 minute has 60 seconds, how many seconds are going to be in a degree? There's 60 minutes, each has 60 seconds. So I'm going to say there are 3,600 seconds in 1 degree. It's the same idea as time. There's 3,600 seconds in 1 hour. All right, so we're going to break down. We need to be able to do it. So what I'm going to ask you to do is give me a decimal for the angle that has 27 degrees, 10 minutes, and 45 seconds. 27 degrees, 10 minutes, and 45 seconds. So what we're going to do to get a decimal is I'm going to take that 27 degrees. And what I'm trying to do is convert all of this to a single degree. So I'm going to take my 27. And then I'm going to add 10 minutes. 10 minutes, in terms of a degree, is 10 out of 60. So I'm going to put my minutes over 60. And then for my seconds, I'll put my seconds over 3,600. So to convert these, we're going to put our minutes over 60, our seconds over 3,600. We're going to add these all together and round into 3 decimal places. That's approximately 27.179 degrees. 60 minutes in a degree, 3,600 seconds in a degree. So that's where I'm getting these two numbers. One line is minutes, 2 lines is seconds. All right, so try number 12 for me. Negative 139 degrees, 50 minutes, and 17 seconds. Pause it if you need to. I'm going to start here in a second. All right, so this one's a little bit different. What I have is a negative angle. So to make a negative angle work, I'm going to take out the negative sign, and I'm going to take out the degree. I'm going to take out the negative sign and the degree. So I'm going to take this number and go 139 plus my 50 over 60 plus my 17 over 3,600. Very important. Take out the negative sign and the degree and put it in the parentheses and do the math from there. So I'm going to say 139 plus 50 over 60 plus 17 divided by 3,600. My answer is going to be a negative 139.838 rounded degrees. Negative angles, ignore it until you get to the answer. Don't use it as a negative 139. Use it as a negative angle. Do the math on just the number, and then put that negative sign in the degrees on the outside. Very, very important. All right, now we're going to draw these in standard position. And that's going to wrap up the lesson once we do these. All right, so we need to have a general idea where they're going to be. All right, we're going to do the best we can to put them close to the right position. They don't have to be exact, but they need to be close. All right, so I'm going to start with a 30-degree angle. All right, 30-degree angle is going to be somewhere in the first quadrant. My thought process on this is a 30-degree angle in the first quadrant. I'm going to take that first quadrant, cut it into 3 pieces. Because my first line would be 30 degrees, 60 degrees, and then 90 degrees. So I'm going to try to separate that first quadrant into angles that will help me. All right, so 90 degrees can be broken into 3 angles, each of them being 30 degrees. So that means I'm going to want to be about a third of the way up in the first quadrant. That's my 30-degree angle. And I want to be halfway. I want to be a little bit less than halfway. That's my 30-degree angle. So decide how we can look at it and break it up into pieces that will help us. All right, negative 250. All right, I'm going to rotate down this time. So when I see negative 250, I'm going to break it up into good angles. Okay? 250, I can at least rotate 180 degrees. So if I take out that 180 degrees, that means I'm going to need to do an additional 70 degrees. We want to look at good angles. Okay, and 180 is a good one. So to draw this, what I would say is I'm going to rotate down 180 degrees, and then I need to go an additional 70. Okay, if I went an additional 90, I'm going to erase this in a second, I go all the way to the top. But I don't want to go all the way. I only want to go 70 of those 90, so I'm going to say I'm going to stop approximately, let's call it here. And that's negative 250, where this angle that I left behind would be approximately a 20-degree angle. They don't have to be exact, but they need to be close. All right, 750 degrees. 750 degrees is a real big one, so I'm going to break this one up too. In 750, I have 2 full rotations, 2 360s. And then I need an additional 30 degrees. So I'm going to look at 750 as 360 plus 360 plus that leftover 30. So to draw this, I need to go around. 2 times to start. That's my 720. Now to get the rest of it in my head, I'm going to think, okay, 30 degrees breaks it up in 3 pieces, so I'm going to finish this angle by going that additional 30 degrees. That is a 750. Look for good angles. That'll give you, like going a quarter or halfway around. All right, try negative 520, so pause it if you need to. All right, so I'm going to say 360 and 160. 1 full rotation, and then 160 degrees. So going down, 1 rotation puts me here. I'm going to think of 160 as being approximately, or not, I mean exactly, 20 degrees short of 180. So I'm going to draw that angle. All right, so in terms, you want to look at 90s and 180s and 360s and break it down into smaller pieces so you can draw some good angles. Last part's radians. All right, 5 pi over 4. All right, so I'm going to do the same idea. 5 pi over 4 to me is 4 pi over 4 plus 1 pi over 4, where 4 pi over 4 is just pi, which is a good angle in radians. So I'm going to have to rotate halfway around and then go an additional pi over 4. So my halfway around, my 4 pi over 4 puts me to here. Now, we probably know what this is, but I'm going to show you a way to think of it. Okay? Pi over 4 means I want to take my pi and cut it into 4 pieces. So my next pi is down here in the bottom. But I only want to go 1/4 of it. So I'm going to look at this and break that pi into 4 equal places. So I want to go 5 pi over 4. We know that this is 4 pi over 4, and I need to go 1 additional to put me at 5 pi over 4. If I wanted 7 pi, I'd go 5, 6, and put myself over here in the 4th quadrant as 7 pi over 4. So taking a pi, either the top or the bottom, and cutting them into a certain number of pieces may help you count. But we all should know that pi over 4 is a 45-degree angle, so that was not as bad. All right, last one. Negative 2 pi over 3. If I'm going fast, I don't have anybody to go off of, rewind, listen to it again, send me an email, do something. All right, negative 2 pi over 3 means I'm going to rotate down. And I'm going to rotate down 2/3 of a pi. So my first thought is, this is down 1 full pi. Right? I don't want to rotate 1 full pi, I want to rotate down 2/3 of a pi. So I'm going to take this pi and cut it into 3 pieces, being 1 piece, 2 piece, and 3 piece. So I have 1, 2, and 3 pieces of my pi. So I'm going to rotate down 1, 2 of those. And this angle over here, make it a little thicker so we can see it, is negative 2 pi over 3. So I broke that pi, that bottom pi, into 3 pieces and counted to the second line. All right, so all this stuff we have to be able to do. We have to be able to convert. We have to be able to draw. We have to be able to state where quadrants we're in. All right, a lot of little things. Hopefully nothing too crazy. If it is, talk to me somehow. All right, you have an assignment, web assign, due by next class. If you have any questions, please, please, please let me know.